Welcome, students. In this second module of chapter number 3, Chemical Reactions and Equations, we will be learning what is a balanced chemical equation. We will study various steps in balancing a given chemical equation. Also, we will see various types of chemical reaction. In that, we will be studying combination reactions in detail. Let us learn how to balance a given chemical equation. Before that, let us know what is meant by a balanced chemical equation. If the number of atoms of the elements in the reactant are same as the number of atoms of those elements in the products, then such equation is called as a balanced equation. Now, let us see one example. Here, in the given chemical equation, AgNO3 reacts with NaCl and gives AgCl and NaNO3. Let us make a table. In the first column of the table, we write the symbols of the elements that are involved in the given chemical equation. So, let us see the elements involved in the given chemical equation. So, here the elements involved are silver, nitrogen, oxygen, sodium and chlorine. Now, in the second column of the table, we write the number of atoms of each of these elements on the reactant side. So here the number of atoms of silver is 1. The number of atoms of nitrogen is also 1. The number of atoms of oxygen are 3. The number of atoms of sodium is 1 and the number of atoms of chlorine is also 1. Now, in the third column of the table, we write the number of atoms of each of these elements on the product side. So here the number of atoms of silver is 1. The number of atoms of chlorine is also 1. The number of atoms of sodium is 1. The number of atoms of nitrogen is 1. And the number of atoms of oxygen are 3. So here we have found that in the given chemical equation, the number of atoms of the elements in the reactants and in the product are same. Such equation is called as balanced chemical equation. Therefore, we can say here the given chemical equation is balanced.
Now we know what is a balanced chemical equation. Now let us learn how to balance a given chemical equation. Here is an example. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. Now, as you can see, the given example is in the word equation form. So, the very first step is to write the given word equation in the form of a chemical equation. For that, we have to write the chemical formulae of all the reactants and the products. So here we have formula of sodium hydroxide is NaOH. Formula of sulfuric acid is H2SO4. Formula of sodium sulfate is Na2SO4 and the formula of water is H2O. So this is our chemical equation for the given word equation. Now next step is to compare the number of atoms of the elements on the both sides of the equation. So first, let us list down the various elements involved in the given chemical equation. So here we have sodium, oxygen, hydrogen and sulfur. These are the elements involved in the given chemical reaction. Now we have to write the number of atoms of all these elements on the reactant side and on the products side. So here number of atoms of sodium on reactant side is 1 and the number of atoms of sodium on product sides are 2. Number of atoms of oxygen on reactant side are 5 and the number of atoms of oxygen on the product side are also 5. Number of atoms of hydrogen on reactant side are 3 and the number of atoms of hydrogen on product side are 2. The number of atoms of sulfur on reactant side is 1 and the number of atoms of sulfur on product side is also 1. So, here you can see we have to balance the number of atoms of sodium on reactant and on the product side. Also, we have to balance the number of atoms of hydrogens on reactant side and on the product side. Next step is to start balancing the chemical equation from the element in the compound which has unequal number of atoms on both the sides of the equation. We have the equation NaOH plus H2SO4 gives Na2SO4 plus H2O. Now, it is convenient to start balancing an equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider that the element in this compound which has unequal number of atoms on the two sides. Now, here in the equation, there are two components Na2SO4 and H2SO4 which contain the maximum number, that is 7 atoms each. So any one of them can be selected. So let us select the compound Na2SO4. Now here let us check the number of sodium atoms on the reactant sides and on the product side. So here we have number of sodium atom on reactant side is 1 and the number of sodium atom on the product sides are 2. So here we have to make the number of sodium atoms on the reactant side as 2. So always remember that it should be the formula of compound cannot be changed while balancing the number of atoms. It means that here to make the number of atoms in the reactant as 2, the formula NaOH cannot be changed to Na2OH. Instead, a factor 2 will have to be applied to NaOH. So, our equation becomes as 2NaOH plus H2SO4 gives Na2SO4 plus H2O. We have the given equation as 2NaOH plus H2SO4 gives Na2SO4 plus H2O. Now let us check whether this equation is balanced or not. We find that the equation is not balanced as the number of oxygen and the hydrogen atoms are unequal on both the sides. So, let us first balance the hydrogen atoms in the reaction. We have number of hydrogen atoms on the reactant sides are 4 and number of hydrogen atoms on product sides are 2. So, apply a factor 2 to the product H2O for balancing the equation. So, we get 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. So now we get the equation as 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Now let us check whether this equation is balanced or not. So here you can see there are 2 sodium atoms on the reactant sides and also there are 2 sodium atoms on the product side. There are 4 plus 2, total 6 oxygen atoms on the reactant sides, and also there are 4 plus 2, total 6 oxygen atoms on the product sides. For hydrogen, there are 2 plus 2, 4 on the reactant sides, and there are 2 into 2, that is 4 on the product side. Sulfur atom is only 1 on the reactant side, and also there is a 1 only sulfur atom on the product side. So, it is seen that the number of atoms of all the elements are equal on both the sides. It means that the equation is balanced now. So, the last and the final step, we write the final balance equation as 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. We saw that in chemical reactions, reactants get converted into the new substances called products. During this, some chemical bonds in the reactants break and some new chemical bonds are formed so as to transform the reactants into the products. In this chapter, we will be studying the types of reactions in detail. Chemical reactions are classified into the following 4 types in accordance with the nature and the number of the reactants and the products. So, the 4 types of the chemical reactions are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Now, let us study all these 4 types of reactions in detail. Let us learn combination reaction. For this, let us do one activity. Take a small amount of hydrochloric acid in a beaker. Pour some ammonia solution into the beaker containing warm hydrochloric acid and observe the change. You will observe that ammonia gas coming from ammonia solution and hydrogen chloride gas coming from warm hydrochloric acid reacts to form the salt ammonium chloride in gaseous state first, but immediately due to the condensation process at room temperature, it get transformed into the solid state. As a result, a white smoke was formed, as you can see in the picture. The chemical reaction for this can be written as ammonia, that is NH3, reacts with hydrochloric acid, that is hydrogen chloride gas coming from the acid, gives NH4Cl, that is ammonium chloride in gaseous state, means in the form of white smoke, as you can see here in the picture. Let us do one more activity. Here, magnesium strip on burning in air gives a white powder of magnesium oxide, as you can see here in the picture. The chemical reaction for the same can be written as magnesium 2Mg plus O2 gives 2MgO. Let us do one more activity. Take water in a beaker up to half of its capacity. Now add a few pieces of slaked lime, that is calcium oxide, to it. Calcium hydroxide, that is CaOH twice, is formed by combination of calcium oxide and water with generation of large amount of heat. Now let us write the chemical equation for this activity. CaO, calcium oxide, reacts with water and to give calcium hydroxide, that is CaOH twice, along with large amount of heat. Now we have seen three activities. You will observe that in each of these three activities, two reactants react with each other and give rise to a single product. Such type of reactions are called as combination reaction. Let us define combination reaction. When two or more reactants combine in a reaction to form a single product, it is called a combination reaction. Some other types of chemical reaction we will study in next module. Thank you.